Okay, so this video is meant for geometry students. We do have a test on Wednesday or Thursday. So here are some problems from sections 1.6 through 1.8. Remember, your test covers the entire chapter 1 and section 2.6. So make sure if you want a full review, you watch both videos that have been made so far. So here's the first question. We're going to construct an angle so that it is congruent to the given angle. So I don't have tools, so I'm just going to kind of walk through and talk about what should be done, try to do my best to draw accurately. So the first thing we have to do is we have to create a point, D, and a ray. And again, it's not going to be straight. I have a straight edge. This is going to be one side of our new angle. Okay, now we come to our angle C here. We need to open our compass, and we need to create an arc in the angle, like so. Now, this arc must also be made at D. So I'm going to use orange. So at D, about the same, it should be the same compass setting. We're going to make an arc. Okay, there we go. Notice I made it big enough because the other side of the angle has to go through that orange arc. And now I have to measure, I'm going to use blue to show you, between those 2 points. This is the width of your angle. So if I label this, let's call this X and Y, you have to measure X, Y. And then you have to put that over here, let's call this point M. You have to put your compass that is set to X, Y on M and now create an arc like so. This arc must intersect your other arc. So my compass is on M and I put an arc mark there. Where these two arcs intersect, that is the second point I need to draw my other part of my angle in green. And there's my congruent angles. So make sure you're doing both of those measurements with the compass to get that intersection of those arcs right there. Again, watch the videos if you have questions. Let's do another construction of a perpendicular bisector, okay? So here's your segment that you're going to bisect. So first thing we do is we take our compass and we open it to more than halfway across. So if I think that this is the midpoint right here, I'm going to go a little bit farther, so from A to here. And what I'm going to do is I'm going to take my compass that is set on A, and I'm going to make an arc right above it. And I'm going to take that same setting and make an arc right below it. And then I'm not going to change my compass setting. I'm going to leave the compass setting alone. I'll come to B, and I'll do the exact same thing. I'll make an arc, and I'll go down and make an arc. And where those two arcs cross, these are the 2 points that you will connect with a line that'll be the perpendicular bisector of segment AB. There you go. And again, my drawing is a little tough, but there you go. There's your perpendicular bisector. Pretty simple construction, the perpendicular bisector. Okay. Again, watch those videos if you're at all unsure about how to complete these constructions. All 4 will be on your test. Okay, 3. We need to find PQ to the nearest tenth and the coordinates of the midpoint. And here are P and Q. Well, PQ is distance. So PQ is equal to x2 minus x1 squared plus y2 minus y1 squared. You cannot afford to mess up the formulas. If you do, it's going to be bad news, so don't do it. Now here, I'm going to label my points. Let's call P x1, y1, and Q x2, y2. It's just a good thing to do to label your points. And we plug them in. x2 is negative 1 minus x1 is negative 4. Notice the 2 negatives next to each other. y2 is positive 1 minus y1 is negative 5. Again, notice the 2 negatives next to each other. This is all inside a square root. So we make the minus minus plus plus. Negative 1 plus 4 is 3. And 3 squared is 9. 1 plus 5 is 6. 6 squared is 36. We need to add those together. We get 45. And my handy-dandy calculator will tell me what this is to the nearest tenth. And the square root of 45 to the nearest tenth is 6.7. So there's your distance from P to Q. So that's part A. Now part B wants the midpoint. I'm going to slide down just a little bit. So for part B, I need to find the midpoint. And to find the midpoint, we have to use the average of the x's and the average of the y's. So I'm going to go left to right here. So x1, negative 4 plus x2, which is negative 1, divided by 2. And the y's, negative 5 plus 1 divided by 2. That is negative 5 over 2 and negative 4 over 2. And you can leave this as negative 5 halves, or you can do the decimal, negative 2.5. I don't care. And the second one simplifies to negative 2. And there's the midpoint. Okay, number 4 here, different kind. Find the coordinates. Oh, I'm sorry, wrong question. Sorry. Hold on just a sec. Alright, so again, I apologize if that confused you, but here's the problem I want to do for number 4. This is one of those different problems. It says the coordinates of point T are given. The midpoint of segment ST is also given, 5, negative 8. Find the coordinates of point S, and point S is the other end point, okay? So in this problem, you are given T. T is right there at negative 2, 8. You're also given the midpoint M at 5, negative 8. But you need to find the other endpoint S. Call it X and Y. So to do this, I'm going to use the midpoint formula. Midpoint formula is, and again, just keep writing it down so we remember, x1 plus x2 over 2, y1 plus y2 over 2. Just keep writing it down. So to find the midpoint between S and T, we would set up this equation. So the midpoint is x plus negative 2 over 2, y plus 8 over 2. That would be the formula we would use. But we know the midpoint. The midpoint is exactly 5, negative 8. So what we can do is we can take the two equations, or the two midpoint representations, and set the x-coordinate equal to the x-coordinate, the y equal to the y. So x, this becomes minus 2 over 2, equals 5, the x-coordinate, and y plus 8 over 2 equals the y-coordinate of negative 8. We are going to multiply, so to solve, we're going to multiply by 2. The 2's cancel, x minus 2 equals, and 5 times 2 is 10, and then we'll add 2 to both sides, and x equals 12. On the y-coordinate, we'll again multiply by 2. Y plus 8, the 2's cancel, equals, make sure you multiply negative 16, and we'll subtract 8, and we'll get negative 24. So the coordinates of S, our other endpoint, are 12, negative 24. Be aware when they give you the midpoint versus when you have to find the midpoint. Okay? Again, you can do it graphically too. Just make sure you show me the graph. All right. I prefer the algebra way. 5. Find the area of the shaded region. All angles are right angles. So here's this picture. It's an irregular shape, so we must break it apart so that it becomes regular. Now, if I draw dotted line there, dotted line there, I believe, I've created 3 regular shapes. One is here, and then these 2 are the same. So to find the area of the first one, area of 1, that's just a rectangle, base times height. Now, this 20 is the base. But see this 18? This 18 goes all the way across. So that's not the height that we use. We have to keep in mind that this 5 here, this is 5 from there to there. So what is left over? If this is 18, the whole thing, and this part's 5, then from here to there is 13. That's the height we want to use for this rectangle, 13, for this area box 1. So that is going to be 0, 6, 260. That's 260 meters squared. That's the area of the first rectangle. And then the bottom 2, they are the same. They're both squares, s squared. The side length is 5. So that means that each area is 25 meters squared, but there are 2 of them, so times it by 2, and we get 50 meters squared. So then the area of the shaded region, area shaded, is equal to 260 plus 50. That is 310 meters squared. And there's the area of that figure. So be careful of the measurements and make sure you break it up appropriately. Alright, 6 here. This is one of your in-class problems. I think it's worth doing. A square and a rectangle have equal areas. The rectangle is 64 centimeters by 81 centimeters. What is the perimeter of the square? So, first thing, the area of the square equals the area of the rectangle. So, eventually we'll have to use this idea to go from one figure to the other. Now we're going to start with the rectangle. They give us the base and height of the rectangle. So, we're going to find the area of the rectangle first. The area of the rectangle is base times height. So the area of the rectangle is 64 times 81. When you multiply that together, 64 times 81 gives you 5184. Now this is the area of the rectangle in centimeters squared, but this is also, because of this idea, this is also the area of the square. Okay, so now how are we going to use that? Well, let's bring that up here. Area formula for a square is s squared. Now, I want the perimeter of the square. So to find the perimeter formula for a square is 4s. So I need s. So somehow I have to use the area formula to find s. Well, the area of the square is 5184. To solve for s here, I can take the square root. That is what gets rid of squared. So if I take the square root of 5184, I get s to be 72. This is 72, and these cancel. That's s. S is 72 centimeters. So that's the side length of each side of the square. So now, just take that and plug it in over here. So we're going to take that, put it right here. The perimeter is 4 times 72. The perimeter is 288, and that is in centimeters because it's perimeter. So there's the perimeter of your square. So kind of an interesting problem going from a rectangle to a square using that fact that the areas were the same. Alright. Okay, last problem here. Number 7. We need to find the area of the shaded figure. Okay, and this is a CD. You guys might be so young you don't know what CDs are. Hopefully you do. A CD has an open center. Okay, so we're going to find the area of this shaded region right here. So what we have to do is we have to find the area of the big circle and then subtract the area of the small. So in a nutshell, to find the area of the shaded, we have to take the area of the big minus the area of the small. That's what we're going to do. Okay, so let's find the area of each one. Let's find the area of the big. Area formula, pi r squared. Now, they give us the diameters. The diameter of the big is 120. To find the radius, take 120, divide by 2. That means the radius is 60 millimeters. So to find the area of the big circle, pi times 60 squared. And when I multiply that, 60 squared times pi, I get, I'm going to round it to no decimals just because of the nature of the problem. 113, oh no, let's round it to 113, and then the 7 makes the 9 round up to a 10. So that's it, roughly. And that's millimeters squared. If you do one decimal, I don't care. But there you go, 11,310 millimeters squared. That's the area of the big circle. Now let's find the area of the small one. Area of the small. Now again, the radius this time, or the diameter, is 50 millimeters. So to find the radius, we need to take 50 and divide by 2. And that is, of course, 25 millimeters. So there's our radius for the small. Pi 25 squared. So the area of the small circle is 1963. Again, I'm rounding to no decimals just because I choose to. 1963, and that's millimeters squared. So now to find the area of the shaded, we go to our formula. Take the big minus the small, and we get roughly 9347, and that's millimeters squared. Okay, so thanks for watching the video. hope this helps, and we will see you on Wednesday or Thursday. All right, happy studying. We'll see you later.